part of identifying electron transfer reactions is identifying reduction processes and oxidation processes. Electron transfer, the gaining and losing of electrons, is so common that it has a language associated with it. So let's start with some of the definitions, and then we will see how oxidation states can help us with the identification. Reduction is defined as a process where one or more electrons is gained by a chemical species. Oxidation is defined as a process where one or more electrons is lost by a chemical species. You might already see that in an electron transfer reaction, both processes must be occurring, where one species gains and the other loses. Now, it's important to remember which is which, and a couple of tricks have been developed by students to help. You might have heard of oil rig. Oxidation is loss, reduction is gain. Or maybe you know Leo the lion says grrr. Losing electrons is oxidation, gaining electrons is reduction. However you remember this, using one of these or by some other way, you need to know the definitions. We're going to use oxidation states to identify reduction and oxidation processes. What we are really looking for are atoms whose oxidation state changes on going from the reactants to the product. The change of oxidation state indicates that electrons have been gained or lost. We know that reduction occurs when a chemical species is gaining electrons. If we think of this as gaining negatives, we look for the oxidation state to go more negative. Oxidation occurs when a chemical species is losing electrons. If we think of this as losing negatives, we look for the oxidation state to go less negative or more positive. In order to do this correctly, we need to assign oxidation states accurately, meaning that we need to know our rules. Let's try some examples. In the first, we have copper 2+ going to copper 1+. These are monoatomic ions, so their oxidation states are the same as their charges. Since the oxidation state is going less positive, which is the same direction as going more negative, the copper is gaining electrons. Using oil rig or Leo says grr, gaining electrons is reduction. In our next example, carbon monoxide goes to carbon dioxide. Using the oxidation state rule number 5, each oxygen has an oxidation state of -2. That gives an oxidation state of +2 for carbon in CO and +4 for carbon in CO2. While oxygen does not change, carbon goes more positive, from +2 to +4. Going more positive is the same as losing negatives, and losing electrons is an oxidation. In our third example, we have ClO2, 1-, going to ClO3, 1-. Again, each oxygen has an oxidation state of -2. Given the overall 1- charges on the ions, the oxidation state of the chlorine atom is +3 in chlorite and +5 in chlorate. Going from +3 to +5 is going more positive or losing negatives. Losing electrons is oxidation. Our final example has sulfur going to hydrogen sulfide. By rules, sulfur as an element has an oxidation state of 0. The hydrogen atoms in hydrogen sulfide are each +1, resulting in an oxidation state of -2 for sulfur. Since the sulfur atom goes more negative, this is an indication of gaining negatives or gaining electrons, which is a reduction.